Today we're going to be talking about constructible numbers. We say a real number alpha is constructible if we can construct a line segment with length absolute value of alpha with only a unit length segment, a compass, and a straight edge. For all these examples, our unit length segment is going to be of length 1. We can also construct angles and other stuff like that, but we're going to be getting into that later on in the video. So now we're going to be walking through how 2 is constructible. So we first start off with our unit length segment, and as I said before, this is going to have length 1. We then go in with our compass and place each side on each side of that line segment and then create a circle. It doesn't have to be a full circle. I stopped there just because we don't really need it. You then go in with your straight edge and connect one side of that circle to the other point on that line segment. And by geometry, we know that since the radius is 1, we've just doubled the radius, and therefore that whole diameter there is of length 2. Now we're going to be showing how we can copy a line segment. So right now I'm just drawing the line segment using the straight edge that we're planning on copying. You then go in with the compass and again place each side of that compass on both sides of the line segment, lock it into place, and then carry that to a different place on your paper or whatever you're using. Then mark it and draw a quarter circle or just a little bit of a circle, just overall marking that spot, and then going in with the straight edge and connecting that point we marked to a point on that circle. We would have just copied the line segment there. Okay, so now we're going to be showing how we can add multiple line segments. So here, suppose we are trying to add up the different line segments A, B, and C. We start off by drawing a different line segment using the straight edge, then going in with the compass and measuring A, then going on to our new line segment and marking off that length A using the compass, then again going back and marking B, and then placing that compass on where we had marked off A, and therefore that line segment is of A plus B, and then going ahead and doing the same thing with line segment C, and then again marking that off. Then we know that from the beginning to that last point we just placed, where I've placed that compass, is of the length A plus B plus C. Now we're going to be showing how we can copy an angle, and this is a very useful tool when creating parallel lines. So suppose this angle here is the one we are trying to copy. We first go in with a straight edge and draw that straight line there. It doesn't have to be any sort of length. And then going in with our compass, we place one end where the angle is and marking a little quarter circle there. It doesn't have to be any specific distance. Then keeping that compass locked where it is, we go into our new drawn line and mark that same kind of quarter circle, half circle. Then going in with our compass again, we mark that specific length there and place the compass on the end so we have that same distance, like so. And then we just go in with our straight edge and mark that last point we created and connect that with our starting point on that line segment. And there we have copied that angle. So now we're going to be showing how we can divide a line segment by 2. So suppose this is a line segment we are trying to divide. We start off with our straight edge, creating some sort of line off of the end of that segment, then going in with our compass and marking a point on that newly created segment. This is not a specific distance we're marking off here, but you do want to ensure that it is the same distance, keeping that compass locked for that second point. This method does work for creating n amount of equal segments here. So you then want to go in with the straight edge and hoping to make this perfect here. It takes me a little bit to get it just right. You then want to use the straight edge and create some line segment connecting that last mark we created with the end of the line segment we're aiming to divide. And then again going in here and keeping that at just the right angle and marking that first point, just like that. And therefore we have divided that line segment into 2 equal parts. Now we're going to be showing how we can construct perpendicular bisectors. So we first want to start off using our straight edge and creating some sort of straight line there. Then going in with our compass We're going to place 1 point on the end there. And again, this is nowhere specific that we're marking with the compass, just you need to make sure that it is over halfway. We then mark that distance there, creating a sort of half circle, as so. And then you want to do the same thing on the other end of the line segment, so moving it, and then again, nowhere specific, they don't have to be the exact same spots, and creating that half circle again. And we know through geometry that by connecting where those two circles meet, their intersections there, I'm going to do it with a pink pencil here. Again, going with the straight edge to make sure that it's a perfect line. Like so. And by doing so, we know that that pink line we've just drawn there is a perpendicular bisector of that first line segment. Now we're going to be showing how we can construct a 90-degree angle. So we first start off drawing a straight line using the straight edge, then creating some sort of point directly above that straight line. Then going in with our compass, we place one end on that point we created and the other on the end of the line segment, creating a circle with the center being that point. We then go in with our straight edge and create a line using the center of the circle and the second point of intersection between the circle and the line segment there, just like that. Then connecting that newly created point with the end of the line segment, we then know that that angle right there is a 90-degree angle. Now we're going to be showing how we can construct the square root of 2. So here we're going to be starting off with our line segment of length 1, and using that compass, we're going to be putting each end of it on each end of that line segment and creating a circle like that. And we know that it has radius of 1, obviously. And since we have already shown perpendicular bisectors, we know that we can go ahead and connect the center of that circle with a perpendicular line, just like that. And we can connect both ends both points that we have created on that circle. We also know that that other line, that perpendicular line, is of length 1 because it's the radius. And therefore, by Pythagorean's theorem, we know that that newly created line segment there is of length square root of 2. So the last thing we're going to be doing here is proving this theorem that the set of constructible numbers forms a subfield F of the field of real numbers. So in order to do so, we first need to show that F is non-empty. We also need to show that if A and B are elements of the constructible numbers, that A plus B is an element in F, A minus B is an element in F, A times B is an element in F, and A divided by B is an element in F. We've already shown that F is non-empty earlier in the video. We've also shown that we can add line segments, and from there it's pretty easy to see that we can subtract them. It's also important to note here that for A divided by B, B cannot equal 0. So now we're going to be showing that A times B is an element in F. So we start off with our line segments of length A and of length B. We've already shown that we can add line segments, so we can create some line segment of length B plus 1. And using that straight edge, we can create some line segment there off of the end point of that first line segment, B plus 1. We are also able to mark off where length A is on that top line segment there, and therefore we can do it with B and 1 on that bottom first line segment we created. We can then mark off or connect points A and 1. And using copying angles, we can connect the end of that first line segment with the other point on that last line segment we drew. And we can call that extra point X there, and we know that that top is A plus X, and the bottom line segment is 1 plus B. Therefore, we know by similar triangles that 1 plus B divided by A plus X is equal to 1 over A. And thus by cross multiplying, we know that a plus ab is equal to a plus x, and therefore we can subtract a from each side, and we know that ab is equal to x. And thus we have shown that ab is constructible. So now we're going to show that a divided by b is an element of the constructible numbers, and remembering that b cannot be 0 here. So again, we start off with our line segments of length a and b, and therefore, as same reasoning as above, we know that we can create some line segment of length b plus a, and again, creating some sort of line off of the end point of that line segment. We can mark off where 1 is using the compass, and again, we can do the same, marking off where b and a are. We can then connect our points, marking 1 and b, and again, using copying angles, parallel lines here. We can connect the end point, therefore the line segment with length a there, with another point on the line segment, and we're going to call that extra spot x. And again, just pointing out that we know that bottom line segment is of length b plus a, and that top one would be of length 1 plus x. And thus, by similar triangles, we know that b plus a is equal to, or b plus a over 1 plus x is equal to b over 1. And thus again, by cross multiplying, we know b plus a is equal to b times 1 plus x. We can then divide that b over, and we know b plus a over b is equal to 1 plus x, and thus b over b plus a divided by b is equal to 1 plus x. Then subtracting 1 from each side, we know that a divided by b is equal to x. Thus, we know that a divided by b is constructible, and therefore we have finished the proof, and we know constructible numbers form a subfield of the reals.